series. Hang on, let me just zoom in. Now, hey. Come on, guys at the front now, come on. I'm just zooming in here. Okay. So last time we were looking at series. And what we're going to do today is look at sequence and series together, but for a very special type of sequence, one we talked about a little bit already, sequence called an arithmetic sequence, or an arithmetic series. So, sequence and series, there's one word we can use for both, and that is progression. So if I write down, for example, let me just write down here. Oops, the pen's not on. Okay, now we're on. No. Right. Come on. There we go. Right. So, arithmetic progression. Arithmetic progression is just a general name for both arithmetic sequence and arithmetic series. So often I just call it AP for short, but this is for both sequence and for a series. And what's special about arithmetic is that the next term is always the last term plus a fixed number. So, like for example, some arithmetic sequences might be something like 5, 7, 9, 11, etc. In this example, you start at 5. Start at 5, and then each time you add 2. So this is an example of an arithmetic sequence. So what we'll do is we'll try and make it more general. So we won't use particular numbers. If I can scroll down a bit. So an arithmetic sequence looks like this. We start with some number, we call it A, and then we add a number to it, so we'll call that D. And then the next time we add the B again, so this time it'll be 2 of them. And then here it'll be 3 of them, and then 4 of them, and so on. So this is what an arithmetic sequence looks like. If you can write this much down here, you don't need the example if you know the word, but you'll need to write at least this down because we're going to have a look at some formulas now. So if you can write that down. So a little bit of vocabulary. Does anybody know what we call the A in the arithmetic sequence? It's called the first term, yeah? And the term that you add each time, the D, yeah, difference or common difference. So in the example I gave you earlier, the 5 would be the A and the 2 would be the D. Okay, so if we can write that much down, let's have a look at some formulas then.
So all of them are common differences and the first one is the first term.
Well, the common difference is what you add each time. Okay. Continue? Yep. So let's have a look at our first formula. Guys, come on. First formula. So if you were to look at this and you wanted to write down a general formula, this, if it helps, this is the first term, this is U1, this is the second term, U2, this is U3, U4, and this is U5. So you should see a pattern here. Each time we get A plus, and it's not quite N, it's N minus 1. So for the fourth term, you add 3D, and for the fifth term, you add 4D. So this is our first formula. This is the formula for a sequence. So this is an arithmetic sequence. So if you know the A and the D, you can work out any term. In the example I gave you earlier, where the A is 5 and the D is 2, let's work out the 100th term. So for example, the 100th term will be 5 plus 99 times 2. So that's 198 plus 5, 203. So that would be the 100th term in the sequence I showed you earlier. Yeah, that's okay? Get the idea? Okay, so let's do an example where we have to use this formula. So let's say something like, let's do something else instead. Let's say, as another example, find the nth term. So in this example, I don't tell you what number it is. In the last one, I said the 100th. In this one, I just said nth. So find the nth term in the sequence 1, and then 4, and then 7. Add 3 makes 10. Is that right? I'm adding 3, yeah. Dot, dot, dot. Okay, let's have a look at this. So the first thing you need to say is what's the A. So what's the A here? 1. And the D? 3. So using our formula, we get UN equals 1 plus n minus 1 times 3. That's equal to 1 plus 3n minus 3. That's equal to minus 2 plus 3n. Yeah? Now we can check that this is right. So if I if I write down U1, the first term, minus 2 plus 3 is 1. If I write down U2, the second term, minus 2 plus 6 is 4. And if I calculate U3, I get minus 2 plus 9, 7. So if I jump now to, let's say, the 10th term, for example, although that's not a big jump, it'd be minus 2 plus 30, which is 28. So by having the formula, you can easily generate and calculate any term in the sequence then. Okay, so that's a simple one to get started. Let's do another one like this. How many terms are in this sequence? So we'll say something like 0, 4, 8, dot, 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 and then this sequence finishes at 48. So in this one, I want to know how many terms we have. So we know that the answer is at least 4 because we can see the first 3 and the last one, but it's not going to be 4 terms. It's going to be more than that. I skipped over many of them, and I want to know how many I do have. So how many do we have? So the way we do that is again by using the same formula. A equals 0 and D equals 4. So UN equals 0 plus n minus 1 times 4. So that's 4n minus 4. And you can check this. If I put in n is 1, what do I get? I do get 0. And if n is 2, I do get 4. I want to know how many terms I have. So I really want to know what is this one. Yeah. If this is UN, I want to know what the n is. Like, is it U10? Is it U12? In other words, how do I make the last one? So all I do is I make UN equal to 48. Yeah, and I get this. So then I get 52 equals 4n. So n is equal to 13, is it? So the last term was the 13th term. That makes 48. So this sequence has 13 terms in it. Okay, good. Okay. So what we'll do is we'll do another example and then we'll do the next formula. What's wrong? Oh. Okay. So I tell you, if I can scroll down a bit, the sixth term is minus 21 and the 16th term is minus 61, and the question is to find A and D. So this is interesting because I only give you two terms in the sequence, A and D. But that's enough. I only give you two terms in the sequence, the 6th and 16th, and I ask you for A and D, and it's enough. We have enough to find A and D. So we know that the sixth term is equal to minus 21, and we need the 16th term to equal minus 61. The sixth term, if it's arithmetic, which it is, A plus 5D is equal to minus 21. And the 16th term is A plus 15D equals minus 61. And all of a sudden you realize that you actually have two equations with two unknowns. And not only that, the A is already the same in both cases. So it makes it really easy to solve. We just subtract. They're gone. That's 10D. And that's minus 61. Is this minus 40? So what's the D? Minus 4. And I can just put that back in here to get the A. So I get A minus 20 equals minus 21. Is that right? Yeah, so then A would equal minus 1. Yeah. Question? A plus 5D, yep. That's from here. That's from this one, which is because I said the sixth term is minus 21, and then I told you the 16th term is minus 61, that's this one. And that one went there, and then this one went to there, and I solved them. Yeah. Okay. Yeah, you have this? Yeah. Okay. Can I scroll down to the next one? It looks like most people have it. Zoom in, scroll in. 3 more seconds. No, one more sip of coffee. Okay, next one now. So we'll have a look at series next. We want to add all the terms together, okay? So what we're looking for is a formula for what I call Sn. And Sn is just the sum. So basically it's short for this. From 1 to n of the sequence. It just means add the first n. It's like this. U1 plus U2 plus U3 plus ... plus, and the last one is UN. So we are going to look for a formula that can easily add all the numbers together. Okay. Right, so let me make a bit more space. So if I want Sn, that means I want to add A plus, and then the next term is A plus D plus, and then the next one is A plus 2D plus. And by the way, what's the last one? A plus n minus 1D. And what's the second last one? A plus n minus 2. Whoa, D. And of course there are many, many more in the middle, of course. So we want to try and simplify this into one nice, neat little formula. And the trick for doing that, I don't know if actually anyone remembers this proof from high school. Yeah, it's to write it backwards. So we have Sn equals A plus n minus 1d plus A plus n minus 2d plus, and then this continues all the way to the end, which would be A here, A plus d, A plus 2d. So what we'll do next is we'll add them together. So here we'll have Sn plus Sn is 2Sn. And something interesting happens here when we add A plus A plus 1, A plus n minus 1d. And I'll do that on the side to show you. So if I add A plus n minus 1d, that's A plus nd minus d. Isn't that right? Yeah. Why is that? No. Nobody fixed me. A plus A, yeah, which is 2A, plus nd minus d, which is 2A plus, well, I guess I should, what? I don't even know why I did that. N minus 1d. The A's add together. And if we add the next two together, A plus D, and then A plus n minus 2d. So let's do them together on the side. A plus D plus A plus n minus 2d. So together that's 2A plus nd minus 2d, and then don't forget about this one here, plus d. So that's 2a plus nd minus d. So that's 2a plus n minus 1d. And what's interesting is that that is the same answer as what I got when I added the first two together. So this is going to happen for all of them. You'll always get this when you add them together. 2a plus n minus 1d. So if I go back here, this will now be 2a plus n minus 1d. But the next one will also be 2a plus n minus 1d. And it continues like this until the very end, plus dot dot dot, etc. So the first one's the same, the second one's the same, they're all the same. So when you add the same thing to itself many, many times, that's the same as doing what? Multiplying. You know, if I did 4 plus 4 plus 4, that's the same as 3 times 4, yeah. So the real question is now, how many of these do I have? I have n of them, of course. So you have 2Sn equals n multiplied by this. 2a plus n minus 1d. So you realize you're just one step away from having a formula, divide by 2. And now we have our formula for Sn. Sn equals n over 2, 2a plus n minus 1d. So this is our second formula for today. Okay. Now you don't need the proof for the exam, but I think it's good to see these things. Okay. You don't need the proof for the exam, but it is good to see these things. You definitely need the formula, of course. So for this lesson there are two formulas, one for sequence, and now this is the one for series. You can write this down, please. Very important formulas.
This is for
series, and the last one was for sequence.
Series is
Add.
progression, right?
No, progression is the name, it's like the family name for sequence and series. Like you have progression and there's sequences and there's series. It's almost like the general name for both sequence and series.
So what's arithmetic mean?
Arithmetic is like arithmetic meaning add.
Oh.
So each thing you get by adding to the last one. So
So-
arithmetic's an adjective that means, addition, adding.
So that's actually a series, right? Arithmetic.
No, arithmetic's just really an adjective. You need to put something with it, like an arithmetic sequence, an arithmetic series, arithmetic progression. You can't really just say it by itself. You can't say that's an arithmetic. Yeah?
So is it fair to say something like geometric progression?
Yeah, you can say it's geometric progression, geometric sequence, geometric series, but geometric again is an adjective, so make sure if something follows it. Yeah. Okay, so let's look at this formula in action then. Can I scroll down? Yep. So, let's say I want to add together this sequence of 100 numbers. So, the series will be 1 plus 2 plus 3, and then that, of course, continues all the way up to 100. So if you think about this, this is an AP problem. The first term, a equals 1. And what are we adding each time? 1. And we know how many terms we have there. It is there? 100. So if I use my formula, we can get S100 equals 100 over 2, that's n over 2, 2a plus n minus 1 times d, which I think is 5,050. Can someone check that, please? Is it 5,050?
Yeah.
It is 5,050. Okay. You needed a calculator to check that? Yeah, 5,050. So, if we add all these numbers together, we get 5,050. And I want to show you that in an Excel program. Because again, I think it's good to actually see exactly what you're doing. You're doing a formula that will help you to add things together very, very quickly. So let's make our sequence. The first term is 1. Come on, wake up. Yeah. And the second term is 1 plus the previous term because it's arithmetic. So the third term is 3. So let's jump down to the 100th term. There it is there.
But it wasn't 3 plus the previous term, it was 2 plus a 1 there, wasn't it?
No, it's 1 plus the previous term. That's this sequence here. Yeah. So here we want to add up these numbers. So the function is sum, and it's from A1 to A100. And you see we get 5,050. Okay, so this is what you're doing. By using this formula, you are literally adding all of these numbers together, but in one step. So it's very, very convenient this way. Okay, so if you can write this example down, and then we'll look at something that's a little bit more difficult. So this example is nice because it's very clear what the A and what the D and what the N is. Let's look at an example now where the N is not clear, we just know the A and the D. We can scroll down, yeah? Right, so let's say I have a sequence like this. For example, I want you to calculate this series. Minus 1 plus 0 plus 1 plus dot 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 all the way until you get to 24. So in this sum, what's the A? Minus 1. And the D is 1. We're adding 1 each time. And the N? No, gets people every time. No, it's not 24. We have to work it out. Yeah, because we don't know what it is. We just know the last one is 24. But I showed you earlier today how you can calculate what the n is by using the sequence formula. un equals a plus n minus 1 d. What's un? 24. Minus 1 plus n minus 1 times d, which is 1. So you get 25 equals n minus 1, so n equals 26. So now I have my n and my a and my d. I can calculate the sum. The sum of the first 26 terms is n over 2, 2a plus n minus 1 times d. So what's that? 26, which is 13 times 23. So what's that? 230 plus 39. 269, is it? 299, is it? Oh, sorry. 299. 299. Yeah. This is more like what would be in the exam. It's just, this is way too easy for the exam. If they give you the A and the D and the N, then all you're doing is just typing it into this formula. It's way too easy for the exam. It needs to be at least this level of difficulty for the exam, where you have to find one of the missing numbers. The A, the D, or the N. Okay. So if you write that down, we'll look at something a little bit more difficult now.
Sir?
Yeah.
I'm kind of confused why you put n minus d in the formula in the end.
Which formula?
You know how...
Oh, the proof.
Yeah.
No, don't worry about it. It's the term previous to this, so it has to be 1 unit smaller. So you take one away from it. For example, if the last term was the 10th term, what would be the second last term?
9.
The 9th. So how did you do that? You did 10 minus 1.
What
So,
about the first three then?
well, if the first term is 1, what's the second term? U2. And how did you get that? By adding 1. So the next one would be U3. So you add another D. Don't worry about it. Like I said, the proof's not on the exam, so this is not something to worry about. What you need to worry about is using the formulas. Yeah. Okay. Let's go on to the next example. Please, no writing on other students. Thank you. Thank you. Yes. 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 Okay. Next example now. So in this example, I'll tell you what the sum of the first 12 terms are. The sum of the first 12 terms is 630. And, no, I'll do this. I'll make it harder. Harder is good. The sum of the first 13 terms is 585. And the sum of the first 29 terms is 2929. Okay, 2,929. Yeah. So we'll do this one. What? I know I can solve it. I don't know. No. I'll give you time at the end to practice some. Okay, let's look at this together. So I tell you the sum of the first 13 terms is 585. So that means you know that n over 2, 2a plus n minus 1 d, oh sorry, and we know the n is 13, so n minus 1 is 12. That should equal 585. And likewise, you know the sum of the first 29 terms is 2929. So that means, again, 29 over 2, 2a plus 28d should equal 2929. So you realize you're in a very similar situation to earlier, where we have two equations. We should clean this up first. Both of these numbers can be divided by 2, so 2 goes into this once and 2 goes into this 6 times, and this 2 is gone. And likewise here, 2 goes into this once, 2 goes into this 14 times, and the 2 here is gone. I should divide by 13, and here I should divide by 29. So now I'm left with 1a plus 6d equals, what's this, 1, 2, 4, 50, 40? Are you sure? You're right. 45. And then this one here is a plus 14d equals 101? Is it? 101, is it? Yeah. Now it's not so difficult. We have two equations. So let's subtract them. A minus A, gone. 14D minus 6D is 8D. And then 101 minus 45 is 56. And 56 divided by 8 is 7. So D equals 7. If I put that back into this one, 45 minus 42, isn't it? Yeah, yeah, that's it. The A is 3. Isn't it? I put the D is 7 into this one. 6 times 7 is 42, isn't it? So A is 45 minus 42. Oh. Oh, here? Yeah. I did the second equation minus the first equation. Yeah. So I don't have any minus signs. You can do it the other way. Look at the same answer. Yeah?
The D put back into the first the initial equation.
Any equation. I chose this one.
To get the
Get this.
final.
Well, yeah. Okay, write this one down. Okay, you have this one? So what I want to do, again, I want to show you that this is the right answer in the computer program. So if I just switch to this for a second and delete everything. So what did I say the A was? It was a 3, wasn't it? And the D? 7. So it'll be the last term plus 7. And how far do I go into this? Up to the 29th term. So I tell you the sum of the first 13 terms is 585. So let's check that. If I jump to the 13th term and type in sum A1 to A13, I should get, what is it, 585, was it? And I do. So we know the answer is right. This works. And then when I go to the 29th term, I think I should get, what was it, 29, wasn't it? Sum A1 to A29. And you see, I do get it. Okay, so we definitely know that this answer is right then. Okay, so if you write this one down, and then there's one more example to do. Okay, so write this one down.
First one, second equation series. Which one is the first one again? UN equals A.
Plus n minus 1d is arithmetic sequence, and then the one with the Sn in it is arithmetic series.
Alright, thank you.
Okay, you have this then? Yeah. Right. Example now. The sequence minus 4 minus 5x, 9 minus 7x, 9 minus 3x is in arithmetic progression. Find x. So what I'm telling you is that these 3 terms, whatever they are, we don't know because there's an x in it, they will make an arithmetic progression. So does anyone have any ideas on how to do this one? Yeah? What do you think?
First sum plus second sum over
True. I think we can do it a little simpler though, but that will work.
Can you not just subtract the first?
Subtracting is what I was thinking, okay? So if you think about it, yeah. Well, look, listen. If it's arithmetic, when I go from the first to the second, I did that by adding some number we call d. And then when I go from the second to the third, I did that by adding d. Yeah? So if I did this, 9 minus 7x minus 4 minus 5x, what should that equal? It should be the d, the difference. It's that should be the same as when I do 9 minus 3x minus 9 minus 7x. So for example, if I have 5, 7, 9, what's 7 minus 5? 2. And what's 9 minus 7? 2. So if it is in arithmetic progression, then the second minus the first should be the same as the third minus the second. And now all we have is just a linear equation. That's all. So we have 9 minus 7x plus 4 plus 5x equals 9 minus 3x minus 9 plus 7x. So I get minus 7x plus 5x plus 3x minus 7x equals 9 minus 9 minus 9. 9, 9, oh, and minus 4. I think I got them all. Did I get that? 9 minus 9, 4 minus 4, 9, 9, 9 minus 9. And then on the left, minus 7x minus 7x, 5x, 5x, minus 7x minus 7x, and that was a minus 3x, so here is a plus 3x. So what have I got in total? Let me see. Minus 14x plus 8x, isn't it?
6x.
Minus 6x. And then here, well, they cancel. Minus 13, is it? So it's a bit messy, but that's okay. X equals 13 over 6. So let's check that this does make an arithmetic sequence, okay? I'll go back to this in a moment. You can write it down in a moment. So what did we say the x was? 13 over 6, was it? Okay. Equals 13 over 6. So we have u1, u2, and u3. What was, please, what was my formula for the first one? 9 minus 7x. And then the next one? The first one was 9 minus 7x. Minus 4 minus 5x. And then the last one? 9 minus 3 times x. Huh? Hang on. 9 minus 3. Yeah. 9 minus 7x. Oh, there's 4 of them. I forgot. Sorry. 9 minus. No, there's not 4 of them. There's only 3 of them. Minus 4 minus 5x. What? That's not it.
Yeah, minus 4 minus
Oh, you gave it to me the wrong way. Minus 4 minus 5x. 9 minus 7x. 9 minus 7x. And then the last one is 9 minus 3x. 9 minus 3x. Okay. So let's check that this is arithmetic. Huh?
Can we check U3 or do we?
No, we'll check the difference. So we'll do the second minus the first, and the difference is 8.66. So this should be the same difference in the next one. And it is. So I actually know what the next term will be. It gets, the fourth term would be this. I can make as many as I want now. As soon as I have the A and the D, then I can know everything. I don't ask you for that, but I'm just making the point. Now that you know what the D is and you know what the A is, here's the A and here's the D. Now you can know everything. Yeah? Okay. Right, so you can...
Did you write the equation how we find the
The D is just the difference between the answers. Now, look, listen, as soon as I have the x, what I can do is put it back in here and then make the 3 numbers. Once I have them as numbers, then it's easy because the difference is just the difference. So I'll write the numbers in. What my first number was minus 14.83, and then the next one is minus 6.167, and then the last one was 2.5. So this is the arithmetic sequence. We found the x. Okay. So if you can write this one down, please. Yeah.
So after the whole number every three, well, not the whole number, but it, the answer looks incorrect every three times, like it's not recurring.
What do you mean?
Every three terms, so that it went from 14.63 to minus 6.167 to 2.5.
Yeah.
And then after the next three terms again, goes to 28.5. Is there anything you could say about it?
Now each of these are fractions. But what's happening is each term will be over 3, except every third term is over 2. So like as a fraction, what's that, 6 and 1/6, it's like 30, the U2 is like 37 over 6, U3 is like 5 over 2. They're all fractions. They're all rational numbers. The only difference is every third term the denominator is 2, everything else the denominator is 3. Or 6 it looks like. No, not periodic. No. The numbers are not repeating. Okay, did you write this down? Yeah.
After we find the difference, we just plug it in the first equation, right?
No, in fact, for this question, you're finished as soon as you find x, because the question was just find x.
Curiosity.
Yeah, and once you have the x, you put them back into the first, second, and third term, and the difference is just the difference between any two neighbouring terms. So you could do the second minus the first, or the third minus the second.
And a, how do we find it?
A is the first term.
Oh. Okay.
Yeah. So once we put x in here, this is the a here, the first term from here. Okay. All right. Did you write this down? Yeah. So this is a again, all of this is in your coursework 1. Yeah, so just to remind you, everything we're doing right now is very relevant for your coursework 1 assignment. And this is a very common exam question. Every exam has a sequence and series question on it. What I like about this question in the exam is I don't feel this question is very difficult in the exam. So it's actually a good question for the exam. So you should try to be really good at these questions, because they are the type of question where you can get 20 out of 20 marks, okay? It's just really straightforward use of the formula. There's nothing special. The only really difficult questions are this one and maybe this last one here. But I don't feel like this was too difficult, because really it's just a degree 2 system. There wasn't anything too unusual about it, okay? So for homework, if you can do A and B. So the homework to try is A and B. Okay, we'll finish there. So, can I close this?
Yeah.